Right, so looking at the bell word. Number one, it says use synthetic substitution to find f of 1. So what goes in the box right here? 1. And what are the numbers that I need after that then? 2, 1, -3, -5. Then we draw an equal sign with a little leg on the bottom. I usually like to cordon them all off completely. What do I do next? Bring the 2 down. Down underneath the equal sign. So I brought my 2 down and then I did what? Multiply it by 1. And I get 2. Add that to the value up above, so 1 plus 2 gives me 3. Multiply with the 1, and that gives me +3. Add that to the value up above, what happens there? Cancels out, I get a 0, but I'm not done yet because I don't have my remainder. We're going to multiply one more time. 1 times 0 gives me 0. Add that to the value up above, and I get what? Negative. So we did our synthetic division, but the question said to find f of 1. So my final answer needs to look like this. F of 1 equals, what does f of 1 equal? -5. This remainder here is what I'm after whenever it says use synthetic substitution. So far, so good? All right, let's look at number 2 then. We are supposed to determine whether or not x plus 2 is a factor. How should I go about determining whether or not x plus 2 is a factor? Can I use a similar process for number 1, or do I have to do something different? I can do something similar. What would go in the box? -2. I would take this right here, set it equal to 0. And solve that for x. X equals -2. This is what I want to put in the box. All right, then my other numbers. What are my other numbers? So just like before, I draw my equal sign. The remainder part off. What am I looking for on this one? I'm going to do the same process, but they asked me a different question, so I'm looking for something different. I want to know whether or not it's a factor. What will I see happen here if it is a factor? I'm going to get a 0 in my remainder. All right, so let's walk through this process. I'm going to bring the 3 straight down underneath the equals bar. And then, Jake, what do I do after that? Times by -2. Jake, what do I get when I times by -2? -6. Add that to the value of above. Taylor, what do I get when I add that? Get a +1. All right, then we're going to multiply again. And what do I get when I multiply that? -2. Okay, what do I get when I add those together? -6. One more time, I multiply these. Alex, what do I get when I multiply those together? 12. And so what do I get when I add those together then? Negative 16. So how would I answer this question? Is this a factor? No, why not?
It has a remainder.
It has a remainder, it's not a remainder of 0. So what I would write to answer this question, the remainder does not equal 0. Therefore, x plus 2 is not a factor. I made this announcement yesterday. I'm going to add this again to today's announcements. If you already made the change in your homework packet, just double check it for me. So everybody pull your homework out for me. Got the little penguin up in the corner. Smaller packet of the two. Little penguin in the corner. I want you to go to question number 6. And on question number 6 in that homework review packet, the one with the penguin, where it said possible, we're crossing that out. We're going after the maximum and minimum. So you're going to have 2 answers on this one. Where it says positive, just make sure that that's crossed out entirely. So double check if you were here yesterday and you caught that announcement and you made that change already, please double check that you have that change. If you were not here yesterday, number 6 in the homework packet, possible needs to be changed to maximum and minimum, and positive just needs to be thrown out. Once you've made that change, go back to the notes packet. We are on page 4, down at the bottom of the page. We did the one up above yesterday towards the end of class. We're going to start with this one today. What do they want me to do on this problem? Find the roots. They told me something was a factor. So I'm going to do my synthetic division. What goes in the box here? Negative 2. And again, I'm always finding that by what it says here. X plus 2, set it equal to 0. X is negative 2. This part goes in the box. What are the other numbers that I need? 4, 19, 19, and negative 6. And since they told me it's a factor, what should happen? Yes, my remainder should be a 0 here. If my remainder comes out to anything other than 0, I either did my synthetic division wrong, or it's not actually a factor. Can you with me? No. All right, so we want to start our synthetic division. What can I do? Bring down that 4. And then multiply it by the negative 2. What is 4 times negative 2? Negative 8. Add that to the value up above. 19 plus negative 8 would give me 11. Abraham, what is negative 2 times 11? Negative 22. I want to add that to the 19 that's above it. What is 19 plus negative 22? Negative 3. Negative 2 times negative 3 gives me what? 6. Add that to the value up above, and what happens? I get my 0, just like I wanted. Okay. So that means But I know now for a fact, if I'm gonna write down my factors. I know that x plus 2 is indeed a factor. What they asked me to find were my roots. What do I know now is definitely a root? -2. Is that the only root that I'm gonna have? No, how do I find the others? Well, on page 4, down at the bottom. We're gonna have to factor. What do I factor? Super close. My 11 was positive or negative? Positive, so 4x squared plus 11x minus 3. We will factor this. So I need my area model, my box. And I'm gonna need my x. We know that A goes here and C goes here. What are A and C? 4x squared and -3. To figure out those two missing boxes, I need the x for that. What goes up here? I have to multiply the A and the C together. -12. Because I'm multiplying 4 and -3. Down at the bottom, I want my B value, which is what? 11. What multiplies to give you a -12, but if you add those same two numbers together, you get a positive 11? 12 and -1. And when I go to put them over here, what do you have to make sure to include? The x's. Without the x's, it's not correct, because remember, everything inside my area model is representing this right here. So I need those x's with it. All right, 2 boxes at a time now. 4x squared and -1x. What's the biggest thing those two have in common? 1 what? 1x. They both have x's, so I can take a 1x out. What about across the bottom where I have 12x and -3? What's the biggest thing that goes into both of those? 3. Positive or -3? Positive. Why is it a +3 and not a -3? It's touching a box that's positive. That 12x is a positive there. So x plus 3 is a factor. I'm going to put that up here. X plus 3. Now we're going to go the other direction right here. 4x squared and 12x. What is the biggest thing that they have in common? 4x. And then going vertically, -1x and -3. -1. There's my other factor, 4x minus 1. So how many roots are we going to have total? 3. You found one of them. You need to find the other 2. I need to take x plus 3, set it equal to 0. 4x minus 1 and set it equal to 0. What do I do right here to get x all by itself? -3 for both sides. I get x equals -3. So that's one of my roots. Then we've got this other guy over here. What do I need to do here to get the x all by itself? Add 1 to both sides. 4x equals 1. Divide both sides by 4, so my other root is what? 1/4. Here's my roots. How do you guys feel about problems like this right here? All right, we've got one more thing to learn. Go ahead and turn to page 5. We're going to do page 5 today. We're going to save page 6 for tomorrow. All right, we've got one more theorem to learn. Yesterday we learned the remainder theorem and we learned the factor theorem. Today, we're going to talk about the fundamental theorem of algebra. The fundamental theorem of algebra says the number of roots or solutions like zeros is equal to the degree of the polynomial. The number of roots or solutions is equal to the degree of the polynomial. The maximum number for roots will always be the same as the degree. This is for real roots. The number of real roots. The maximum is degree. For my minimum, it depends. And again, this is minimum number of real roots. If my polynomial is even, then the minimum is 0. And if my polynomial is odd, so the minimum is 1. So I'm going to have to determine whether it's an even or an odd polynomial before I can answer the minimum question. Let's think about why this is for just a second. An even polynomial would be something like a parabola, because that has x squared as our biggest power. Tell me about the ends on a parabola. They point the same direction. That lowest point on my parabola might not be low enough to touch the x-axis. It might be hanging out above the x-axis and never, ever, ever touch or cross it. So it's possible on an even polynomial, since my ends point the same way, that I never cross the x-axis. What do you know about the ends on an odd polynomial? They're opposite. One goes up, one goes down. It doesn't matter whether it's left up and right down, or left down and right up. Sorry. If one of my ends points up and the other end points down, what has to happen somewhere in between these two ends? Somewhere in between, it's going to have to cross the x-axis at least one time. Otherwise, my ends couldn't be pointing in opposite direction. All right, let's finish this sentence down at the bottom. Number of real roots plus the number of imaginary or non-real roots will always equal the degree of my polynomial. So I want to use these ideas right here, maximum, minimum, and then real plus imaginary equals degree to answer these two questions down here. So let's look at number 1 first. What is the degree of the polynomial that they've shown me here on number 1? 3. Right here is my degree. So what is the maximum number of real zeros then? 3. Same thing as my degree. What is the minimum? 1. 3 is an odd number. So we have 1 for our minimum. All right, and then they tell us if there are 3 real roots, how many imaginary roots are there? The way I remember doing this, I'm going to take this sentence up above, number of real plus number of imaginary equals degree, and I remember it with a word. That word is rid. Real plus imaginary equals degree. So if I remember rid, I can find out how many imaginary roots there are. What did they tell me about the roots in this third sentence here? What did they tell me about the roots? There are 3 real roots. I'm going to substitute a 3 in right here. Plus my imaginary equals my degree. What did we say the degree of this polynomial was again? 3. Well, how many imaginary roots must there be then? 0. It's 0 because I have 3 real roots. They told me 3 real ones, plus however imaginaries, and that has to equal 3. We'd subtract the 3 from both sides. So then we get that imaginary root equals 0. Yep. All right, let's try another one like that. Look at number 2. Look at this polynomial with me here. What is the degree of this polynomial? 2. Here is my degree. What is the maximum number of real zeros, real roots? 2. It's whatever my degree is here. What about for the minimum? 0. Why is it 0? Yes, 2 is an even number. So we have 0 as our minimum for real root. All right. I'm going to use my sentence again. Rid, real plus imaginary equals degree. What information did they give me here? Because I have 0 real roots. No real roots. Plus my imaginary roots has to equal my degree. What did we say the degree was? 2. So how many imaginary roots would there have to be? 2. I would take this, I would subtract 0 from both sides. And my imaginaries would be 2. So far, so good? No, we'll get there. Real plus imaginary has to equal my degree. It just has to add together to get me my degree. So what number would you add to 0 to get up to 2 is what it said. Zero real plus how many imaginaries to get up to 2. All right, let's look down at the 2 problems down below. They asked me some questions about the degree. I want to know whether it's odd or even. And then our leading coefficient. We're gonna find our x-intercepts and then we're gonna graph it. So we're gonna bring all these big ideas together today. You need to put those so you can see in the button. For my degree, I'm used to looking for the biggest exponent, but this is in factored form. How many factors do we have? 2 factors. How many of those 2 factors have x's in them? They both do. I have an x right here and I have an x right here. Are the x's raised to any powers here? Nope. Then I just take the number of x's that I've got. 1, 2 of them. And that's my degree. I have 2 x's, so it's a degree of 2. If I had 3 factors and each factor had an x in it, then it would be a degree of 3. If any of the x's had an exponent on it, say this one was an x squared, I would count it twice. So if there's an x squared, I count it 2 times. If there's an x cubed, I count it 3 times. And I just look at how many x's I've got there. Is that even or odd? Even. Since I have an even degree polynomial, what does that tell me about my n's? Same direction. N's are going to point the same direction. Look at the leading coefficient now. Where do you look for the leading coefficient? Could be right after my equal sign. When it's in factor form, I go right after my equal sign. Well, what's right after the equal sign? Positive. There's no negative numbers there. In fact, it's an invisible what? An invisible 1. It is invisible as well. Since my leading coefficient is positive, what does that tell me about my n's? Going up. Which side goes up according to this? Right side. Remember, leading coefficient only ever tells me about my right side. How many x-intercepts are we going to have? 2. How do I find them? Yep, equal both of those factors to 0. X plus 3 equals 0. X minus 2 equals 0. And then I'm going to solve both of these for x. So what would I do to x plus 3 equals 0 to find my x-intercepts? Subtract 3 from both sides. So I get x equals what? X equals -3. I'm going to write that on the line right here. And I'm going to go plot it on the graph. On the x-axis, I'm going to go to -3 and put a dot. This other one, x minus 2. What do I do to find that x-intercept? Add 2 to both sides. So x equals +2. I'm going to go put that on my graph. So x-axis, +2. What did you tell me that we know from up above about my end behavior? Leading coefficient is positive, and so what does that mean about my picture here? Tell me what to draw. What's going up? Right side's going up. What's the left side doing? It's also going up. So I've got that much of it. In between these two, do you see how the line is coming out of the top of both of these? I need to connect the bottoms. They already have lines on the top. I'm not going to have more lines out the top. But there's nothing coming out the bottom, so I need to take the bottoms and connect them. Makes kind of a parabola shape. Actually, this one wouldn't be a parabola. I want to do one more like this. And then we'll call it a day. You guys okay with that? We'll be in this. So looking at example number 2 or equation number 2. What is my degree here? 3. 1, 2, 3 x's here. X, X, I have 3 of them, so that is my degree. Even or odd? Odd. What does that tell me about my ends then? They go different ways. My ends. Point opposite ways. Positive or negative leading coefficient? Negative. Looking right after the equal sign right here. What does that tell me about my ends then? Right side's going down. All right, all we need to do now is find our x-intercepts, our zeros. We are ready to graph this. So I have x plus 2 equals 0. X minus 6 equals 0. X minus 1 equals 0. Talk to me about the first one. Yep, minus 2 on both sides. So x equals negative 2. There's one of my roots. I'm going to go plot it on the graph. Right here. What about the middle one? I have to add 6 to both sides. So x equals positive 6. There's another root. I go plot that one on my graph. 1, 2, 3, 4, 5, 6 is right here. And the very last one. X equals 1. We're going to add 1 to both sides. Plot that on my graph as well. What do I do with those 3 dots now? Right side's going which way? Down. Down, because we had a negative leading coefficient, so I make that side point down. What do I do over here on the left side? It's going up. Why is it going up? It's odd, so they're going to go in opposite directions. And now I need to connect these together, but I need to not leave out that dot in the middle. So here I have a line coming out the top, right? So I'm going to take it from the bottom of this dot and connect it to the bottom of this dot. What do you think it's going to look like in between those two? Yep, it's going to be up over the top. I'm going to connect the top to the top. Very nice work today, guys. Tomorrow we only have 2 problems left to do. We're going to bring all of these ideas that we've been working on for pretty much the last 2 modules together. We're going to do this right here. But first, we're going to have to use longer synthetic division. Synthetic division, and then we're going to have to factor things so that we can find our roots, our x-intercepts. You guys have the rest of the time to work on any homework that you have for theory.